Hello, this is Scott White. Today I wanted to talk on a visual proof of the Pythagorean Theorem. There are many ways to prove the Pythagorean Theorem, but we will use some triangles and do it visually. If you recall, the Pythagorean Theorem talks about the sides of a triangle and the relationship between the sides of a right triangle. Our triangle here, the nice orange one, we'll call the short side is side A, the longer side is B, and the longest side here, the hypotenuse as it's called, is C. So we have a right triangle with sides A, B, and C. The Pythagorean Theorem said that A squared plus B squared equals C squared. This theorem is accredited to Pythagoras, who lived in Greece from 569 to 475 BC. What's interesting is that this theorem can be traced back to much older times. There's actually a clay tablet from Babylonian times dated to 1750 BC that has the Pythagorean triples written on it. A Pythagorean triple would be three sides that make up a right triangle, similar to maybe like a 3, 4, 5 right triangle, or a 4, 6, 8 right triangle. So while there are many ways to prove it, we will do this visually. So if we want to use our little visual aids here, and I've got a few more triangles to use, we want to make a square where the dimensions of the square are C. So each side of the square would have length C. That would give us an area of C squared. So the area of the geometric figures we use to create that would be C squared. So how can I arrange my triangles into an area of C squared? Well, I want the outside, this would be length C, so that would be on the outside of my square. So if I kind of arrange these and put them together, work my jigsaw puzzle, I can come up with an area that would represent C squared. But I'll need a little space in the middle, so I have a handy blue square which drops right in the middle. So there we have an area of C squared. It's a square where each side is of length C. It's made up of 4 right triangles of A, B, and C sides, and then a square in the middle. Well, what are the dimensions of this square in the middle? Well, if we look at this, this is length B, right? And the length is B minus this length, which is A. So the length of our little square in the middle on each side is B minus A. Now, how do I take these pieces and arrange them to represent B squared plus A squared? Well, let's see. If this is side B, I probably want that on the edge of a square, so I can put this one over here maybe. So I have side B there, but only A here, so I need something longer down the side. Maybe we'll put this guy down here, and we can match him up, which is good. Now, if I put this piece in here, I can see that this is side B, this is side A, this is actually B minus A, so this whole side would be B. So in here I have a square with dimensions B squared, and what's left out here is side A, and this length will be side A, so I have A squared. So now we can see that we've taken the same amount of area that was originally C squared and rearranged it to be A squared plus B squared. So visually, this basically proves the Pythagorean theorem that for a right triangle, A squared plus B squared equals C squared.